Hello everyone. This is the video for systems of linear inequalities. This would be on level 3 of our A4 standard systems of equations. So the learning target is I can solve a two-variable system of linear inequalities by graphing. Okay, so solving a system of linear inequalities is very similar to the graphing by hand method, which we did probably one of the first things we did in the school year if you are in Algebra 2. We do have a couple differences though. We will need to determine if the line will be dotted or solid, and we will need to shade the common region that the lines share. Okay, so some prior knowledge here, you're going to have to think back to when you graphed linear inequalities in Algebra 1. Okay, so just a quick little refresher on that, as you can see in the speech bubble. When you graph a linear inequality, so an inequality meaning you have a greater than symbol, a less than symbol, greater than or equal to, or less than or equal to, okay? These represented different types of lines. So if you did not have the or equal to sign underneath your greater than or your less than, so you did not have a line underneath your sign, that line was dotted. Okay? And it was dotted because that meant your line was not included in the solution. It was everything that was greater than or less than. And then if you had the or equal to sign underneath your greater than or less than sign, that was a solid line because it's inclusive. Okay, your line was included in that solution. Okay, you might also remember that there's a shading portion as well. Okay, we'll get to that in a little bit, but we're no longer concerned with one point where two lines cross. We're concerned with an entire shaded region. Okay, so what I'm going to do is I'm going to zoom in a little bit, just a tad. Okay, so we've got two lines here. We've got y is greater than 6x minus 5, and y is less than or equal to negative x plus 2. Okay, so what I am going to do is I'm going to switch colors here. So let's make my top line here a red line, and we'll make the bottom line a blue line. Okay, so a couple things right off the bat. Let's determine whether these are going to be dotted or solid lines. Okay, so taking a look at our symbol here, we've got y is greater than 6x minus 5. Because of this greater than sign, that means this is going to be dotted. Okay, so this is information that we really don't even need to do anything. No algebra or graphing required. We can get that right off the bat. So for our second equation, our blue line, we've got y is less than or equal to negative x plus 2. Okay, because we've got a line underneath our less than symbol, meaning it is equal to, it is inclusive, that is going to be a solid line. Okay, so now what we can do is we can just go ahead and graph these lines. So for our red line, we have y mx plus b. The y is isolated, so we know it's in slope-intercept form, so no math required. We can just go ahead and graph this thing. So the y-intercept is negative 5, so I can go down to negative 5 on the y-axis. And then my slope is 6. To turn that into a fraction, I can put a 1 underneath, so it's 6 over 1. So that means from here, I can go up 6 and to the right 1. Up 6 more to the right 1. We could also go down 6 and to the left 1, but my graph only spans from negative 10 to positive 10, so I'm going to be off the graph for that. So now what I can do is I can connect those lines, or connect those dots with a big old line. I'll extend it in both directions. And I'll add some arrows, because it extends infinitely in both directions. Okay, and it's a dotted line, so what I need to do is put a couple marks in here to show that it's dotted. Perfect. So now what I can do is I can go ahead and graph my blue line. My blue line is also in slope-intercept form. My y-intercept is positive 2, so I'll go up to positive 2. I'll make my first point. Okay. From there, my slope is, it appears as if there's no number in front of my x or no coefficient, but there's this negative sign, so it actually means my coefficient is negative 1. So negative 1 over 1 means I go down 1 to the right 1. Because my slope is negative, it goes down from left to right. So I'll make a bunch of points here. Again, I'm really only looking for 2. But I know my graphing and my work is much more exact if I'm putting all the points in. It takes a few extra seconds, but it's something that I think is worth it. Okay, so now I can connect those points with a line. And I can throw some arrows on it. Okay? And of course, I'm not going to get my eraser out and make it dotted because, as I said up here, it is a solid line. Okay? So previously, when graphing systems of equations or using the graphing by hand method, okay, we would stop here. Okay? But because I've got greater than and less than or equal to, those are inequalities, I know that I've got a shaded region that I need to find. Okay? The shaded region represents the variety of solutions I can have. Okay? Because remember, if we had, y is greater than 5, that means y could be 6, y could be 7, y could be 8. So there's not just one solution, there's going to be several solutions. Okay? So what I need to do is I need to find a test point. Okay? So a test point is going to be a point that I am going to plug into the top and bottom equation for x and y and evaluate my equation, or my inequality in this case. Okay? So what I will do is write test point. And the test point that I always like to plug in is 0, 0. And I plug in 0, 0 because they're just, zeros are easy numbers to deal with. They just cancel things out. Okay? So if I've got 0, 0, I can rewrite my top inequality as 0 instead of y. Okay, so that's that 0 right there. Is greater than 6, and instead of x, I'm also plugging in 0, minus 5. Okay, so if I keep simplifying, I get 0 is greater than, 6 times 0 is going to be 0, minus 5. And 0 minus 5 is negative 5. So I've got 0 is greater than negative 5. Okay, so if I evaluate this right here, meaning I just take a look and see whether it's true or false, for my red line I get 0 is greater than negative 5 if I plug in the point 0, 0. Well, this is true. Okay? So that's great, but what does that mean? That means if I go over to my line here, I'm completely ignoring the blue line. Whoops, made a mark there. Completely ignoring the blue line because I'm not concerned with that right now because I just plugged in 0, 0 into my top equation. We plugged in 0, 0 and we got true. So that means 0, 0 is kind of on the left side of this red dotted line. Okay, we've got a left side and we've got a right side. So we plugged in 0, 0 and it was on the left side. Because it was true, it means that 0, 0 is a solution to this inequality. So what that means is all points that are on the same side as 0, 0 are going to be true. So that means my shaded region is narrowed down to this space right here or this little triangle up here. Okay? So 0, 0, just to recap, was true. Because it was true, that means all things that are on the same side as 0, 0 are going to be true. So what kind of helps me is I like to make these little arrows here that are just pointing to the left so I don't get confused. So now what I can do is I can do the same thing for my blue line. So for my blue line, I'm also going to plug in 0, 0. So if I do that, I have 0 is less than or equal to negative 0, which sounds kind of silly, plus 2. So if I keep evaluating, I've got 0 on the left side is less than or equal to negative 0 is just 0 plus 2. 0 plus 2 on the right side is going to be 2, so I have 0 is less than or equal to 2. So if I evaluate that, 0 is less than or equal to 2, well, that's true as well. Okay, so same thing. I'm going to ignore my red line for right now. I'm just taking a look at this blue line. So the way the blue line splits this coordinate plane, it kind of looks like a top and a bottom. You could say it's a right or left. I'm going to say top or bottom for right now. Doesn't matter. So we plugged in 0, 0. 0, 0 is below this line. It's on the bottom half. Okay, and it was true. So that means all points that are on the same side as 0, 0, so in this case the bottom half, are going to make this inequality true. Anything above is going to make it false. So that means, along with 0, 0, all the points down on this side of the line are solutions. So what we're going to do now, because we've narrowed it, or when we plugged in 0, 0 for our red line, and we narrowed it down to this top triangle in this kind of bottom corner here, and then we did the blue line and we narrowed it down to this section right here, or this little triangle down here, the common section that satisfies both lines is to the left of the red line and below the blue line. So that leaves us with this chunk down here. So what I'm going to do is I'm going to shade this region. Okay, this is our shaded region. Let's zoom in a little bit. Okay, and you don't need to spend a whole lot of time shading, just so we get the point. There are some students who like to shade every single box, and it's a little bit of a waste of time. Fill that in right there, and we are all set. Okay, so that is our shaded region. That is going to make this system of inequalities true. Okay, so that's what I would be looking for. So when we did the graphing by hand method and we did the other methods for solving linear systems of equations, we really cared about the point where the two lines crossed. For linear systems of inequalities, I don't care a whole lot about this 1, 1 where the two lines cross. I care about the shaded region that's going to make this system of linear inequalities true. Okay, so the shaded region is what I would be looking for. Okay, let's move on to our next example. Okay, so here we've got 3 equations, or 3 inequalities rather. So we're going to graph all 3 of these lines. So I am going to make this top line my red line. Whoops, how about I make it red, not purple? Okay, and I've got a less than or equal to sign, so I know this is going to be solid. I've got my blue line, and my symbol is greater than or equal to, so this is also going to be solid. And then let's do an orange line, a little tiger pride in there. And our symbol is greater than, so this is going to be a dotted line. Okay, so I've got my 3 lines. I've got a red, a blue, and an orange. So you might be able to tell here that our difficulty is going to be, we've got lines that are in standard form. So what we're going to start off by doing is getting those into slope-intercept form. Okay, so I'm going to take this red line, and I'll manipulate it down here. Okay, so if I change this to black, I've got 2x minus 3y is less than or equal to 12. So my first step is going to be to subtract 2x on both sides. When I do that, 2x minus 2x is going to cancel on the left side. And on the left side, I'm left with negative 3y is less than or equal to negative 2x plus 12. My next step, I will divide both sides by negative 3. Divide everything by negative 3. Negative 3's are going to cancel on the left side. Now, here's where some mistakes start to happen. Okay? So, as you might also remember with linear inequalities, whenever you multiply or divide by a negative number, you need to flip your sign. Okay? So, I just isolated my y. But because I divided by negative 3, instead of having less than or equal to now, I'm going to change it to greater than or equal to. And then continue on with my equation. So negative 2 divided by negative 3 is going to be positive 2/3. And 12 divided by negative 3 is going to be a negative 4. So this is going to be my red equation that I'm going to graph. Okay, so now we can do the same thing with our blue line. Whoops, I don't like that. Could be a little straighter. So for my blue line, I have x plus 5y is greater than or equal to positive 20. So first thing I'm going to do is I'm going to subtract x on both sides. When I do that, x minus x is going to cancel. So I am left with 5y is greater than or equal to negative x plus 20. So at this point I can divide everything by 5 to isolate my y. When I do that, 5's eliminate on the left side. But because I only divided by a positive 5, I do not need to flip my sign. That is only for negative numbers. So what I'm left with is y is greater than or equal to negative 1/5 x plus 4. So this will be the blue line that I graph. Just change it from standard to slope-intercept form. Okay? And taking a look at my orange line, That's as simple as I can get it, or as simplified as I can get it. So I know this is going to be a vertical line through 0. Okay, so what I'm going to do now is I'm going to graph these lines. Okay, so for my red line, I'm going to start at -4, that's my y-intercept. And my slope is 2 over 3, so I'm going to go up 2 and to the right 3. Up 2 to the right 3. Or I could go down 2 and to the left 3. So I can connect all these points. And put some arrows. All right, perfect. And it's a solid line, so I'm not going to make any dashes or separate this line at all. So now I can do my blue line, also a solid line. So I can start at +4. And from there I can go down 1 and to the right 5. Or I can go up 1 to the left 5. Okay. Connect all those points with a line. Very thankful that that straightens it out for me. Okay, so now I've got my orange line that I can't forget about. So for my orange line, it's going to be a vertical line that goes through 0. Put some arrows on it. But I know this line is dotted, so I need to grab my eraser and erase a few sections here. Okay, make sure it's easy to tell that it's whether it's dotted or solid. Okay. All right, great. So I graphed all 3 lines. So what I now need to do is find the shaded region. So what a lot of people do is they see that there are 3 lines here, so they automatically shade the inside of this triangle. That is not necessarily true. Okay, not necessarily true. We actually need to do the math here. So, because my orange line is crossing through the point 0, 0, I'm going to try a different test point. Okay, some people get a little bit confused when their line goes through their test point with the whole inclusive, exclusive thing. So we're going to pick a different point. How about we go to 1, 1? So this will be our test point right here, kind of inside that triangle. Okay, so for my test point, my red one is going to be 1, 1. So what I'll do is I'm going to plug it into my original equation. Okay, and by plugging it into my original equation, like for this red line, how I had to divide by a negative and I had to flip my sign, if I plug it into my original, I'm not going to, I don't have to worry about this sign flipping as much, okay? Because if I plug it into this slope-intercept form inequality down here, if I forgot to flip the sign, then I'm shading the wrong side of the line. Meanwhile, if I plug it into my original standard form equation, I know that I'm plugging it into a correct line. So, if I do the math here, I've got 2. Instead of x, I'm plugging in 1. And it doesn't need to be 1, 1. You can pick any point you would like. If you'd like to plug in the point 1,000,000, -47, you're more than welcome to do that. -3. Instead of y, I've got 1. And then less than or equal to 12. Okay, so if I combine these, 2 times 1 is going to be 2. -3 times 1 is going to be -3. And then I've got less than or equal to 12. 2 minus 3 is going to be -1. got my 12. So I'm left with -1 is less than or equal to 12. Well, that is obviously true. So if I go to my red line here, I kind of have this top section and this bottom section. I'm ignoring the orange and blue. 1, 1 was part of this top section here, and it was true. So that means my solution has to be above my red line. Okay, so I like to just draw little arrows pointing me in the right direction. So I've eliminated this section down here and this section down here because they are below. They would be false if we plug them in. So now we'll do blue. Plugging in the same test point. So if I do that, I've got x plus 5y is greater than or equal to 20. So instead of x, I'm plugging in a 1. Plus 5. Instead of y, I'm plugging in another 1. Greater than or equal to 20. So if I simplify this, get rid of the parentheses, I've got a 1. 5 times 1 is going to be 5. And of course, the greater than or equal to 20. 1 plus 5 is going to be 6. And then greater than or equal to 20. So I've got 6 is greater than or equal to 20. This is false. So if I go to my blue line, again, I'm ignoring the orange line, the red line. We plugged in 1, 1. 1, 1 was below this blue line, but it was false. So because 1, 1 was false, that means none of my solutions are down below here. So that means I need to draw arrows up above my line because my solution is going to be above this line, away from 1, 1, because it was false. Okay, so that means we're going to shade the opposite side. So because of that, we've eliminated this section and this section as well. Okay, so now let's take a look at our orange line. We've got x is greater than 0. Okay, so for x is greater than 0, we don't need to plug in a point. Okay, we don't necessarily need to plug in 1, 1. If we take a look at x is greater than 0, if we were to plug in 1 for x, okay, 1 is greater than 0. Okay, so that means we're going to shade to the right side of this line. Okay, we plugged in 1 for x, we'd get 1 is greater than 0. That means we're going to shade to the right side of this line. So for my orange line, any number higher than 0 is going to make this true, so we need to shade to the right side. So because of that, we need to be to the right of the orange line, above the red line, and above the blue line. Well, that leaves us with this little section up here. No need to shade every single box. Just enough so I know which area you are talking about. There we are. Okay, we've got 3 more examples. Let's take a look at those. Okay, so I've got a red line and a blue line. The inequality sign for my red line is less than, so this is going to be dotted. And for my blue line, it is greater than or equal to, so this is going to be solid. Okay, so I can go ahead and graph my red line. I'm going to start at the y-intercept, which is positive 8. Make my first point. And my slope is 3 over 4. So I can go up 3 and to the right 4, but I'm going to run out of space. So I'm going to go down 3, 1, 2, 3, and to the left 4. And keep doing that until I run out of space. I will connect them with a line. I'll put some arrows on it. So I know it's dotted, so I'm going to take my eraser out and make a few little dashes in here so it's easy to tell. Another one right here. Okay, so now I can do my blue line. My blue line is going to start at -3. And my slope is -2, so that means I'm going to go down 2 into the right one. Or I can go up 2 into the left one. I will connect those with a solid line this time. Keep extending it. Not the greatest line I've ever drawn, but certainly not the worst. And I will leave it solid. So now what I need to do is I need to plug in a test point. Here, neither of my two lines are going through the point 0, 0, so I'm going to plug in 0, 0. So when I do that, for my top line, I've got 0 is less than 3/4. Instead of x, I've got a 0. Plus 8. Okay, I'm left with 0 on the left side. 3/4 times 0 is going to be 0. And I'll bring down my 8. 0 plus 8 is 8, so I have 0 is less than 8. Okay, and taking a look at 0 is less than 8, this is true. So that means if I go over, well, extended that a little too far. Looks like Pinocchio. Okay. So if I take a look at my red line, ignoring my blue line right now, I've got this top and this bottom. Okay, 0, 0 was down bottom and it was true, so that means I'm going to shade the side that 0, 0 is on. So I'm shading below this red line. So I've eliminated the top sections here, the two smallest corners. Now I can do the same for my blue line. So I have 0 is greater than or equal to -2. Instead of x, I'm plugging in 0 minus 3. If I do the math here, I have 0 is greater than or equal to -2 times 0 is 0 minus 3. I get 0 is greater than or equal to -3. And I know that this is true. So if I go to my blue line, I'm ignoring my red one. I've got this left section and this right section. 0, 0 was in the right section, and it was true, so that means I'm going to shade the side that 0, 0 is on. So that narrows it down to this section down here. Okay, and please don't waste a ton of time coloring. I cannot stress that enough. Some of you are going to do it to be funny. And I will tell you right now, I guess that's just not my sense of humor. There we are. Okay? So I can move on to my second one. Okay, so I have a red line and a blue line. My red line has an inequality symbol of greater than, so this is going to be dotted. And my blue line has an inequality symbol of less than or equal to, so that's going to be solid. So for my red line, I can start at my y-intercept, which is -2. And from there, my slope is -1, so I can go down one to the right one. Or I can go up one to the left one. I'll connect all of those. And put some arrows. Okay, and it is dotted, so I need to get my eraser out, get rid of a few of these dots. Okay, now I'll do my blue line. Blue line, I'm going to start at -5. And from there, my slope is -1, so I'll go down one to the right one. Or I can go up one to the left one. I can connect these with a solid line. And add some arrows. Okay, these lines are parallel, so we've got no point exactly where they're going to cross, but let's find an area where we can shade. So test point, let's do 0, 0 again. Oops, sorry about that, got an alarm going off. So for my test point, I will plug in 0, 0. So if I write my top equation, I've got 0 is greater than -0 minus 2. So if I simplify this, I've got 0 is greater than 0 minus 2. 0 is greater than -2. And if I evaluate that, 0 greater than -2, that is true. Okay, so that means I can go over to my red line. It's got this right section and this left section. So taking a look at this right section and this left section, 0, 0 is to the right side, and it was true, so that means I'm going to shade to the right of my red line. Okay, so now I'll plug in 0, 0 for my blue line as well. So I've got 0 is less than or equal to -0 minus 5. If I simplify, I get 0 is less than or equal to 0 minus 5. So 0 is going to be less than or equal to -5. And this, I know, is false. Okay, so taking a look at my blue line, 0, 0 is to the right of this blue line, not the left. And it was false, so that means I'm going to shade all the points that are away from 0, 0. Okay, so I'm trying to shade the region where they overlap. These two lines are not going to overlap anywhere, so I can just leave it like this. Okay, we'll move on to the last example, and then you'll get to do some practice. Make my top line my red line. There's an inequality symbol that is less than, so this is going to be dotted. And my bottom line is going to be a blue line, and its inequality symbol is greater than or equal to, so this is going to be solid. Okay, I am going to do the math for my red line down here a little bit. Let's make that line a little bit straighter. That's going to annoy me. It's in standard form, so I know I'm going to have to change it. So I've got 11x minus 3y is less than 12. So I can subtract 11x on both sides. When I do that, 11x's are going to cancel on the left side. So I'm left with negative 3y is less than negative 11x plus 12. I can divide everything by negative 3 to isolate my y. So I have y, but because I divided by a negative number, my sign is going to flip. So instead of having less than, I've got greater than. Negative 11 divided by negative 3 is just positive 11 thirds. And 12 divided by negative 3 is going to be negative 4. So this is the red line that I'm going to graph. Okay, just changed it from standard form to slope-intercept form. Okay, so I can go ahead and do that. I'll start my red line at negative 4. And my slope is 11 over 3, so I'll go up 11 and to the right 3. Or I could go down 11 and to the left 3. I'll connect. I'll extend it in both directions. And it's dotted, so I'll take out my eraser and put some dashes in here. Okay, so now I will do my blue line. Taking a look at my blue line, not a whole lot of math that needs to be done. I've got y is greater than or equal to 7, so I know that's going to be a horizontal line through 7, where my y coordinate's always 7. So what I will do is I will draw a horizontal line. And put some arrows. Awesome. Okay, so now I need to do a test point. So I'm going to go right over here, and really I only need to do one test point for my red line. And you can plug it into your manipulated equation down here, but remember, I like to plug it into my original standard equation in standard form, rather. So I am plugging in 0, 0. is 3 times 0 is less than 12. So if I do the math here, 11 times 0 is going to be 0. Negative 3 times 0 is also going to be 0. Is less than 12. 0 minus 0 is going to be 0. So I get 0 is less than 12, which is true. Okay, so I'm going to go over to my red line. Red line kind of splits this into a left section and a right section. 0, 0 is true, so I'm going to shade the side that 0, 0 is on. Okay, now I'll do my blue line. For my blue line, this tells me that I'm looking for any number that is greater than or equal to 7. So if I take a look at my y, any number that's greater than or equal to 7 is above this line. There I go. Get my purple shading tool out. So I need to be to the left of this red line and above this blue line. That leaves me with this little section up here. There we are. Okay, so now it's time for some practice. If you have any questions, please let me know. If you need any additional practice, I'd be more than happy to get you some. Have a great day, and let me know if there are any questions.